Vice President heading the Rapid Prototyping Solution Business Unit at Stratasys. And I'm very pleased and honored to share with you some of our strategy elements for 2017 around prototyping. So, looking at prototyping per Gartner hype cycle, and by the way, it's only the recent years that he had dedicated the hype cycle for 3D printing. So we can see that prototyping is definitely the most mature segment in the 3D printing cycle. It's not in the innovation trigger, not even in peak of inflated expectations. It's really out there at plateau of productivity where mainstream adoption takes off. Where does that meet our customers? Two aspects to this. First of all, those top customers, early adopters, which I've known for many years, used to ask me, just give us the platform, provide the materials, we'll figure it out. Don't bother, to pack it or tell us exactly what's the application. This generation is over. We're still having those early adopters and are excited to continue and do business with us. But the vast majority of the customers or the future customers have no bandwidth and no time to experiment and to try it all. They are looking for a packaged, closed solution. Trend number one. Trend number two, it used to be, as any new technology and new industry, reserved only for the experts. This RP shop manager, the operator at an automotive company, he knows everything inside out. But guess what? The designers are left aside. This is being changed in the recent years completely. The designers, or the back side, if you wish, or if the front side of the workflow, are now taking advantage and would like to understand better and assimilate more prototyping. So with these two trends, A, the need to package a solution, not just a platform and a material, the whole thing, the software and the use case behind it is a leading thing for us in 2017. And secondly, what are we going to offer to designers? So indeed, a mature application, but just to allow you to understand, where this assimilation stands, we are discussing a situation at which 23% of prototypes today are done using additive manufacturing, leaving quite a multi-billion opportunity for all of us to assume and to implement 3D printing for prototypes, because the rest is done using traditional, conventional methods. So it's still the beginning of a road, and we will see exactly what is the untapped potential here, which you can already understand that I will imply to small, medium companies with designer workgroups. So let's get back to the basics of prototyping. What are the essential use cases that we discuss? So a prototyping solution starts with concept verification. This is the initial step at which you just want to flesh out the design. You would like to have an inexpensive material for fast and quick iterations. You would like to make sure that the quality is good, but shouldn't be superb at this point. And again, coming back to the inexpensive material, very, very crucial for this stage. And then you continue to design verification, and here the dimensional stability of the models is crucial. Accuracy, fine details, smooth surfaces. And the last step would be functional performance, where material properties and advanced material properties get into the play, because that's where you would like to test your part to withstand temperature, pressure, strength, stiffness, etc. Now at Stratasys, we already own two technologies. One of them, the PolyJet technology, is all about design verification with amazing 14 microns layer thickness and fine details and accuracy. We really excel with this use case. And we also have the FDM technology, which enables us the usage of thermoplastics all the way to high-performance materials as the Ultem family. And that says it all about functional testing and the ability to test the part in the natural environment that the end-use part will work at. This is how design verification looks like with PolyJet technology. We discuss part realism with clear transparency and surface finish and polypropylene-like properties, thin walls and cavities that could unleash your creativity as designers to practically create anything you think of. And this is the technology that excels in design verification stage. Functional performance looks like that, with strong, durable ABS parts, with Ultem family that enables all the way reaching temperature, heat deflection temperature of 203 degrees Celsius. Nylon 12 family, which just got a new member. We will discuss it later. This is how functional performance look at its best. So let's see an example taken from Automotive. So it all starts with an idea, of course, and then concept verification using 10% of the size and using only single material. Moving on to design validation, this time with simulation of rubber, maybe a digital material made on PolyJet technology with a rigid and rubber material, all the way to full-size part made on our Object 1000, for example, with digital ABS and material simulating plastics. This is a life cycle here. So far, and as I said, we've been very much focused on RP shops, on service bureaus, on those experts. We want now to reach widely a different target audience, which is the design workgroups. But a minute before, about our RP shops managers and what could we offer them, and this is from the house of PolyJet technology. This is the evolution, starting with a single material platform, introducing in 2007 multi-jet system that enabled simultaneously to jet 2 modeling materials. That's where we created 21 digital materials, combinations of rubber and rigid. It was 2014 that we decided to jet additional material. And here we had 3 modeling material being jetted simultaneously to create a world of color made of cyan, magenta, and yellow, and also a world of overmolding with digital ABS, playing 2 modeling materials, and Tango, our rubber-like simulation, enabling overmolding applications. And the last, of course, 2016, our J750, enabling 6 modeling material to be jetted simultaneously, 14-micron layer thickness. And it's all about textures. It's all about full color. 360,000 shades and colors are obtained in this part realism platform. All these solutions are available today for RP shops and for service bureaus and for designers that could afford it. But we know the needs of the designers. We know that small and medium companies with design work groups, they spend about $35K a year on prototyping. We also know that they are the vast majority of this untapped area in the diagram that I showed at the beginning. We also know that the penetration of additive manufacturing is the lowest they have there, less than 10%. And from a different survey that my company conducted, we know that additive manufacturing is addicted. Once you start using it and you see how it shortens the time to market and enables you such a great creativity, you start being addicted to that. So what are the designer work groups' needs? So guess what? They are not willing to compromise. They need quality grade, engineering quality grade. They need, of course, ease of use. They're not going to be, spend all the time of the world to tweak this parameter and arrive exactly to this quality. They wanted just as a green flag setup that they could do immediately. They would like to be able to get to professional levels of productivity, reliability. Again, they need to design and get the concept on the table, move immediately to design verification, all the way to functional performance. And yes, no more compromises on professional RP for designer work groups. That's the main theme for 2017 and 2018 for Stratasys here. So let's see how that is translated into a recently launched solution.
Imagine a rapid prototyping solution that doesn't compromise on what you really need. Engineering-grade quality results, but easy enough so anyone can operate. Professional levels of efficiency and productivity that's available straight from your workgroup office. What you're imagining is the new Stratasys F123 series. Designed for the way you work, this 3D printer is your new team player for smarter prototyping. Empowering professional designers and engineers, the Stratasys F123 series provides end-to-end rapid prototyping for every stage of the prototyping process. Churn out rapid, economically effective concept models in PLA material and fast draft mode. Switch to advanced design validation prototypes for unmatched precision, repeatability, and aesthetics. And test your parts in a wide range of functional FDM materials, including ABS, ASA, and PCABS. Reach new levels of workflow efficiency with proven GrabCAD print software. Print straight from your CAD file. Manage your jobs in real time and from anywhere, whether you're a beginner or a power user. Shrink your lead times. Unleash your creativity. Make the right decisions about your future products today. That's the Stratasys F123 3D printer series. Now that's smarter prototyping.
Ladies and gentlemen, this is the Stratasys F123. We are discussing 3 platforms here, different sizes, different volume of builds, and of course, the powerful FDM technology. And if you recall, the leading use case of functional performance with GrabCAD print software, which is now connected to the vast majority of our products and enable streamlined workflow. So looking at how it really happens in life. So we start with PLA, okay? That's a very inexpensive material we offer with great material properties exactly designed for the concept verification stage. Continuing with advanced material as ASA at a specific 127 millimeter resolution with soluble support exactly for those cavities and complex geometries that really need design optimization. And finalizing always the same solution with PCABS that enables the exact functional testing, strengths, pressure, and temperature resistance as needed for the end-use part. Speaking of the materials, another revolution that is happening here is with regards of price. Thinking that only the RP shop managers will be concerned of the total cost of ownership would be a mistake. Designers group mainly will run a cost center, and they will be very sensitive to the cost per part, and we would like to enable them more and more usage. Therefore, we lower the pricing up to 34% for all the materials that you see here. And on top, a PLA material is priced half of ABS. And the idea is not just to say, hey, we are discounting here. No, the idea is to enable solutions not just to large companies and enterprises, to small and medium companies, to designer work groups, that cost per part matters to them. This is all about the streamlined workflow with GrabCAD. We can now read native CAD files and print directly from CAD using GrabCAD print add-in. It really increases productivity and enables remote print monitoring. This is super crucial for us. Continue and be innovative. So there are 50 new patents with the new Stratasys F123 series and leveraging 43 existing patents. These are all being translated to accuracy, performance, productivity. For example, specialized extrusion algorithms were implemented. Highly tested, optimized materials, tight temperature uniformity, again, to enable PCABS to work on that. Automatic tip detection and calibration, something that is a burden today, and here it's all done automatically. So it's not just about statements, yeah, we have now new patents. These patents translate immediately to the benefits of the world of the designer. And let's see how easy it is just to replace a spool. It's all done within 2 minutes and very straightforward. And at the same time, we can see how easy it is to just remove the tray, which is done in a flexible manner, and remove the part from the tray. And again, ease of use. You don't have to be a mechanical engineer here. You are a designer, you are an engineer of your product, but we wanted this to be very easy for you. And this is our beta customer quote: time is our only product. We can produce multiple design iterations quickly, and we can change a product design overnight to meet a customer's deadline. The parts are accurate and the process is dependable. Jesse Hahn, President, Center of Advanced Design in North America. We continue to work on material innovation, seeing the materials enabler for new use cases and new applications. Two new things that were new materials that were announced recently. On the PolyJet side, with the design verification use case, we introduced the Stratasys Agilus 30 family for superior rubber-like performance. On the FDM side, we introduced nylon 12 carbon fiber field, the first composite material we introduced here, and I will talk about it in a minute. So innovations in the material roadmap are happening all the time, and we are expecting to introduce more this year. So looking at the Agilus family, and we look again at the concept verification, design, and functional. Yes, this solution could do the three of them, but basically it would excel in design verification. So we are discussing here rubber-like simulation with elongation at break of up to 240%, tear resistant, that is 2 times better than anything else that was out there in the market. Let's remember that complex geometries and really superb design verification could be done only with 3D printing, and this is the material that enables that. On top, it's not sticky, easy to handle, and provides new wealth of digital materials that are made of this Shore 30 family that, when composed with rigid material, could create a wide range of Shore values from 30 all the way to 95, enabling all different hardness levels that are needed for design verification. It comes in black and translucent, available first on our Connect 3 platforms, and will be available throughout the year on additional platforms as well. It works with our new soluble support, which again contributes to the freedom of design verification. On a different side, we have a use case of metal replacement prototyping, of functional performance prototyping, this time with nylon 12 carbon fiber. It's our first composite material. The use case would be really to replace metal part, and here the advantage of the stiffness to weight ratio is amazing. Light parts that enables to replace completely metal just due to the fact that the strengths and the stiffness and the specific stiffness are just able to replace metal parts prototyping. 35% chopped carbon fiber by weight is included, and we have done quite some efforts to make sure that the length of the fibers has been optimized to ensure that we have good extrusion and at the same time significantly advanced mechanical properties. This is a start of a family. We had before launched nylon 12 and nylon 6, and now nylon 12 carbon fiber, and we will continue to enrich our materials in order to be able to excel on one hand design verification, the other hand would be functional performance, mainly with FDM materials. So thank you very much. Stratasys has been the forefront of 3D printing for the last 25 years, and we certainly intend to continue and be there. Should you have any questions, please feel free to ask me. Also, we have a few parts here of nylon 12 carbon fiber that I'll be gladly handing to you if you wish to touch and feel this superb stiffness and lightweight. Thank you very much. Okay.